Hi, I'm Justin. Uh, I'm going to talk to you about where gravity comes from, how it's possible, how it works. How does gravity work? It's based on a theory I have, okay? It'll make sense though. To some of you, you'll understand the concept, and it does make sense. Okay, so I did some other episodes where I talked about the mass of objects, the size of space, etc. And I'm going to try and veer away from the size of space. I'd like to stay with the constant, a constant, that space is a specific size, okay? And it stretches. It stretches. Uh, Keeping this in mind, we will get into why I believe my theory on how gravity works, how are things attracted to each other, how this works. Okay, so gravity, obviously, on this planet, we're held down by the Earth's gravity. Okay, our physical being is made up of an array of chemicals and molecules and whatnot that allow us to walk the surface of the Earth, to go above the surface of the Earth, to go below it. But we are built for this planet. So, again, how gravity works. We're going to get into the mass of things again. I know I did this in the last episode, but we're going to touch on it again because I've always wondered where and how gravity works. In fact, I wanted to design a machine or a camera of sorts that we could actually see the magnetic workings of our planet, the magnetic workings of other planets in the sun. We've tried to draw pictures with lines depicting how it looks, and we have equipment that can sense it, sense the strengths of it, whatnot. But being able to physically see it, okay, that's what would be a very neat tool to build. Okay, I'd probably figure out how to do that. It would take some real precision, and very small, being able to see smaller than probably we can right now. It'd be very difficult to make. But maybe this will help in predicting it a little better. When we talk about gravitational waves, which do exist. So anyway, what is gravity? What is it? What is gravity? Gravity is the weak force. Okay. My previous episodes, I talked about how if nothing can get smaller than a certain point, anything with mass is bigger than it. Okay. So space itself is your water. Let's say everything is bigger than that. The second side of space is it wants to be everywhere. It wants to be in the space where that mass is at. The mass actually pushes space out, away from it. Like I said before, it's like putting a marble in water, in a glass of water. The water doesn't shrink into the marble. It's pushed away from it. But when you pull the marble out, the water recedes to its previous level. Space is essentially the same thing. Okay? Anything that has mass is pushing space out. Okay? It's stretching it. It's like an elastic. It's stretching it. Well, that space wants to come back in. It wants that area that the mass is at. So that's our gravitational pull. That's our gravitational well. Okay? Now, every material, every object, everything with a mass has as a gravitational well. Okay, so let's do mass objects in red. Okay, so here's mass. I'll just put an M in it. Okay, there's mass, and it's larger than space. But what happens since mass is in space? And here's where I'm kind of re-referencing the smallest distance, being a sphere or whatnot. So our smallest distance, okay, that nothing can get smaller than that. The spherical shape. Regardless, you'll have a bunch of these, okay? It's all over it's everywhere. They can't touch each other, but they are elastic, okay? So now this object with mass inserted into a space is going to push away the space molecules or the dark matter. It's going to push it away, okay? Now this creates dark energy, okay? Because now there's an energy that's trying to get back in to refill this void, okay? This doesn't have these dark energy molecule, the dark matter molecules inside it, but the dark matter wants to get back in. It creates a dark energy, okay? Something we can't see, because it wants to collapse in on the massier object, okay? It wants that area. So essentially what happens is a massive object, or an object with mass, okay? This could be the smaller than we can imagine, or smaller than, very small. It has mass. It's got a mass, and space doesn't, okay? So essentially it pushes the space away. Space wants to come back in on it, which gives the space a force. It wants to come back in on mass, okay? And that creates an energy, or that energy is basically a gravity, an attraction. The space is trying to push back in on the space the massive, or the mass-containing object took. Alright? Does that make sense so far? Are you getting what I'm saying? I mean, just this simple definition here can't, if we build on, can explain why the planets are the distances they are from the sun, why electrons rotate around protons, and I got into that in the last episode too, how when objects reach a certain mass threshold, the space that's around it actually creates a vortice around the mass of the object. So in a proton's case, an electron is formed. Okay, an electron is a direct result of the space that the proton is using. You got all that inward pressure coming down in on the proton, from space trying to gather itself back together again. Well, in a three-dimensional world, and we talked about all this before, let's just do another sphere here. Let's look at things that we understand. So if this is Earth, or the sun, or whatever, okay, there's the magnetic sphere. You see that? Yeah. There's a magnetic sphere that comes out of our Earth at the poles. Okay, and This is a pretty broad range of stuff I'm trying to cover here, but some of you will be able to keep up, and that's who I'm trying to talk to here. So, we call it magnetic, okay? But it could also be considered gravitational. Now, that could be argued in many different aspects. But our Earth's or our Sun's magnetic field could also be considered gravitational. Okay. I think I had touched on before how when you have a massive object in space, this dark energy molecules, let's call them, or dark matter molecules, are stretched out or pushed out of the way because they can't get in here. They're pushed out of the way. Well, there comes a point where the accumulation of this stretching effect creates a vortice, which happens on the equatorial lines, okay, whether it be a proton or planets or stars, happens on the equatorial lines, okay. A vortice is created, which then creates an electron or a planet, Mercury, and then Venus. Depending on the mass of the object, it will depend on how many electrons it has. But the distance of the electrons, or planets, is all directly coincided with the mass of the object that it revolves around. And we can get into the deeper realms, which is the consistency of the mass. What elements is it made of? How viscous is it? Stuff like that. So basically, the mass of the object times, I don't know if it's multiplied by, the material it's made of will determine how far the electrons are away from the center, or how far planets are away from their star, their host star, or the galactic center. Okay? We can look at the galactic center as just another element on the periodic table. Our star could be an element on the periodic table. It works in basically the same way, just a heavier element. Probably a lot of people disagree with me. That's fine. It's about seeing things in a different way. Okay? So gravity. Gravity is the dark matter being forced away from an object that has mass. It wants to retract in on itself. It can't. But there is an energy there. There is a tension, like I said before, it's like a rubber band. There's a tension there. That is gravitation. Call it magnetation. It's the dark energy that is, the dark matter is space without energy. Dark energy is space with energy. And that dark energy is basically the gravitational pull, or the, cross a line here, the magnetic pull of stars, planets, protons that have electrons. Anything with mass, okay? Again, anything with mass has a gravitational well around it. How things are attracted, the wells, I was through all this before, the wells, when they come close to each other, they get in each other's well, and they stay there or they get separated later. But that's how things are attracted. Gravity. Gravity. this is how gravity works. Okay. But calling it a theory, but the more and more I talk about it, the more and more it makes sense to me. So that is how gravity works. I'd love to hear some questions. I'd love to answer any questions you have, or attempt to explain this in a way where you get what I'm talking about, where you can actually see it. So there we are. Okay, so I'm going to stop this one here, and then I'm going to get into another episode where I talk about how connected we are to very distant places. Okay, thanks.